Okay, we're going to jump into lesson 7.1, 7.2, which is on modeling linear relationships. And so these are going to be some word problems that we're going to set up using linear functions. Most of this time, the linear functions are going to be in standard form, right, which is the ax plus by equals c form that we looked at a couple lessons ago. We'll take a look at the first one here. It says a local charity is selling seats to a baseball game. Seats cost $20 each and snacks cost an additional $5 each. The charity needs to raise $365 to consider this event a success. So first I want you to notice that we have two rates here, right? Which means we're going to have two variables. We've got seats at $20 each and we've got snacks at $5 each, and each of those has a different rate. So I'm going to go ahead and define these variables. First I'm going to call x the seats, and then I'm going to make y the snacks. And you could do it the other way if you wanted to. It doesn't matter which way you label them, x or y right now. And then I'm going to go ahead and attach their values, their rates here as I set up this equation in standard form. So we know that the seats, which is x, cost $20 each, so that's 20x plus 5y, and I'll tell you why we're using addition in a second here. So remember, they need to raise $365, and they get to add up their earnings from both of these to raise that $365, which is why I have the plus sign there. So this needs to equal $365. For now, we're going to assume they want to earn exactly $365. Okay, and now I'm going to go ahead and put this onto the graph, right? Because this is the equation that I came up with in standard form. Okay, and I'm going to put this onto the graph, and I'm going to use x and y intercepts to do it. And remember, we talked about this last time. So first I'm going to solve for the x-intercept here. So that means that this y term is going to disappear because I'm plugging in 0 for y. And so to find the x-intercept, it's going to leave me something that looks like this. 20x equals 365. Right, so I just took the x term, set it equal to our grand total, and I'm going to divide both sides by 20, okay, and I get x equals 18.25. And then to find the y-intercept, similarly to find the y-intercept, I would just plug in 0 for x, which means that that term would disappear there, the x term would disappear, and I'd be left with 5y equals 365. Divide both sides by 5, excuse me, and I'm going to end up with 73. Okay. And so now that I have those intercepts, I can go ahead and put those on the graph. The x-intercept is at 18.25, 0. Notice I've already labeled these x and y axis here, right? You'll have to take a second and pause the video and go ahead and do that on your own. And so we have 18.25, which is just about right here in the middle. Okay, for the seats, and then 73, which is going to put me right about there. And then I can go ahead and connect these here, and then that should give me a good idea of the values that I could use to satisfy this $365 requirement. Okay, so then that means that any coordinate on this line, right, any of these xy coordinates on this line would satisfy this $365 requirement that I'm shooting for. All right, we'll keep it moving here. Let's slide over to number 2. It says a movie theater sells tickets to a new show for $11 each. The theater also sells small containers of popcorn for $5 each. So again, two different rates here, right? We have $11 each for the tickets. We have $5 each for the popcorn. And this theater needs to make $3,086. So I'll go ahead and set up my equation here. First, I'll define my variables. We're going to say x is going to be the tickets, and y is going to be the popcorn. And again, you could switch these if you wanted to. Okay. And now I'll set up my equation here. So it's $11 for each ticket. So that's going to be 11x plus $5 for the popcorn, 5y equals the grand total of 3,086. And there we have our equation. And now we can go ahead and find the intercept so that we can graph this. So same strategy as before, right? If I plug in 0 for y here, that'll give me the x-intercept. So my equation would just be looking like this: x-intercept 11, x equals 3086. Divide both sides by 11 here, and I'm going to end up with x equals 280.5. And then if I plug in 0 for x, that'll give me the y-intercept because the x term disappears there. And so my y-intercept equation looks like this: 5y equals 3086. Divide both sides by 5, and I get 617.2. And so I've got my intercepts there. Notice again, I've already went ahead and labeled my axes here. Okay, we've got tickets and we've got popcorn. And you know what I need to do here? I actually need to flip-flop these around, right? Because we have X as the ticket, so that should be on the X-axis. So let's go ahead and do that together then. So the X is the tickets on the X-axis. And notice I got to get to 280 here, so I'm going to go 100 every other. So each one of these is worth 50, 200, and 300. Okay, and then we'll make popcorn on the Y. And we've got to get all the way up to 617, so I'm going to make each one of these worth 100. 100, 200, 3, 4, 5, 6, and 7. And then we can go ahead and plot these here correctly. So 280 is my x-intercept right about there. Okay, and 617, my y-intercept right about there. And then we can go ahead and connect these. And once again, any of these coordinates that fall on these points would give me an x and a y that would satisfy this $3,086 requirement here. All right, scrolling down here, it says use the graph to approximate how many buckets of popcorn must the movie theater sell if it sells 330 movie tickets. Okay, so for this problem, notice they've got another equation here, right? And they want to achieve this $3,840 limit. They're saying, okay, well, if you sell 330 movie tickets, right? So let's go ahead and check out where that is. 330 movie tickets is going to be right about, let's see, where is it going to put me? Right about here, 330, right? How many buckets of popcorn are you going to need? Well, what I can do is I can just draw up and trace to my line here, okay? And that tells me that I'm going to need about 100 buckets of popcorn here. And that means that if I had 100 buckets of popcorn and 330 movie tickets, then I would achieve this $3,840 limit that I'm trying to get to. So this would be 100 buckets of popcorn. All right, let's move to the next page here. It says determine when the values of these functions will be the same. And we know that be the same, we've talked about this before, this be the same means equals. So I'm just going to take these two equations and set them equal to each other. So we've got 2x plus 4. Notice they're using that function notation there. And that's got to equal negative x plus 8. They're asking me when are these going to be the same, so that's when are they going to be equal. So I set them equal to each other. And now I just go ahead and solve. So add x. And I get 3x plus 4 equals 8. Subtract 4, so that's going to give me x equals, let's see, 4. Oh, 3x equals 4. And then divide both sides by 3, and I get x equals 4 thirds. Okay, and so they would be the same when x equals 4 thirds. All right, same idea here, right? We want to know when these two functions are going to be the same, so I just set them equal to each other. So we'll go ahead and do that. 1/2 x, let's do this. 1/2 x minus 1 equals 3/4 x plus 4. Notice for this one, we've got some nasty fractions, so I'm going to use the fraction bomb method. Remember, the LCD for my denominators in this case would be 4, right? That's the least common denominator, would be 4. So I'm going to multiply all the numerators by 4, because that's the LCD there. Okay. So then it ends up looking like this: 4x over 2 minus 4 equals 12x over 4 plus 16. And all my fractions should disappear here, and that looks like it does happen. So 2x minus 4 equals 3x plus 16. Okay. I'm going to get my x's together by subtracting 2x. All right. And that gives me negative 4 equals x plus 16. And then I'm going to subtract 16 to the other side, and that should give me x equals negative 20. All right. And we'll keep going here to letter C. Same deal, we want them to be the same, so 2x minus 7 equals 0. Okay, so that's when we want it to equal 0. So all we have to do here is add 7 to the other side, so I get 2x equals 7, and then divide both sides by 2, and I get x equals 7 over 2. So when x equals 7 over 2, these functions will be the same. All right, and just a couple more word problems here. It says set up an equation to solve the word problems. Below, Yuma needs a singer. Singer A is offering her services for an initial $25, okay, an initial $25, and an additional $30 per hour, okay, and then we've got singer B here offering his services for an initial $145 and an additional $15 per hour. All right, so we've got singer A, we've got singer B. We want to know when these two singers will be charging the same amount of money. Okay, how many hours is that going to take? So I'm going to set up two equations here, or two expressions, and set them equal to each other. So we've got singer A. So that's an initial $25 and then $30 per hour. So I'm going to say 30H plus that initial 25. And then we've got singer B, and that's $15 per hour plus the initial 145. I want to point out really quickly, remember we talked about this y equals mx plus b, right? Imagine this is y equals mx plus b there. And b is our initial value, right? Our y-intercept. So that's how I'm setting this up. And it's asking when are these two things going to be the same? So I'm going to set them equal to each other. And then I'm going to go ahead and solve. So I'm going to subtract 15h. That gives me 15h plus 25 equals 145. And then I'm going to go ahead and subtract 25 from both sides. And I'm going to get 15h equals 120. And then I'm going to go ahead and divide both sides by 15. And it's going to give me h equals 8. Okay, and remember this is hours. So if I were to use these hours each for 8 hours, then they would cost the same amount of money, right? And so that's what it's asking me to figure out. Next one says Charles has $3,430 in his bank account and makes automatic $490 monthly payments on a utility bill. Okay, so that money's coming out of his bank account because he's making payments. If he stops making deposits to the account, so that means he's not adding anything to the account anymore, when would the automatic payments make the value of the account 0? Well, first let's set up an equation to model what we have here. So Charles has $3,430. That's his initial value. And then he's going down by $490 each month. So we've got $490. And this is each month. And then plus his $3,430 initial dollars. Okay. And keep in mind this is going down, right? So we have a negative $490 there. And then we want to know when is this going to equal 0? When is this going to equal 0? So I'm going to set it equal to 0 there, and then I'm going to go ahead and solve. So we'll start by subtracting 3,430. And that gives me negative 490m equals negative 3,430. And then divide both sides by negative 490. Okay, and a negative divided by a negative should give me a positive there. So let's see, 3,430 divided by 490. And I end up at 7, positive 7. So after 7 months, Charles will have no more money in his account there. All right, thanks for watching.